Okay, this is the next kinematics problem. Problem number 2. The question states, a sprinter can accelerate with a constant acceleration for 2.1 seconds before reaching top speed. He can run the 100-meter dash in 10 seconds. I'm going to do this in 2 separate parts. I'm going to look at the acceleration for 2.1 seconds first. So we have a guy, and he's on a track, and he's going to run for 2.1 seconds. So let's look at his distance, x sub t. The initial point is 0. He's going to start at 0. His initial velocity is also 0 times t, because he's not moving when he starts. Right when he starts, the instantaneous velocity is 0. Plus 1/2 our acceleration times the time. And we're looking at a time of 2.1 seconds squared. Plugging this into a calculator, gets you 2.205a. And this is equal to x sub t. What about the velocity? What happens when he stops accelerating? So at this 2.1 second mark, what's his velocity? That's going to be v of t. That's going to be the initial velocity, which is 0, plus your acceleration times the time, 2.1 seconds. This is just going to be 2.1a. This is the velocity at 2.1 seconds when he finishes accelerating. What happens after that? So we have a total time now, 7.9 seconds, that we need to look at. So let's look at that distance. For 7.9 seconds, that's the time. Let's just assume he starts at 0. His initial point is 0. And his initial velocity is that 2.1a. His initial acceleration is 0. This is going to be times t. And then his initial acceleration is 0. And this is going to be this distance here. Now we don't know what that is. That's just going to be what that distance is there. But we know what the time is 7.9. So this is going to be 2.1 times 7.9 times a. If we take this distance here for the 7.9 seconds and we add that to the 2.1 second distance, it has to equal 100. So that means that 2.205a, which is this distance, the 2.1 seconds, plus 2.1 times 7.9a, this has to equal 100. All right, plugging this into a calculator, let's see what we get. I'm getting A as 5.321 meters per second squared. That's the acceleration for 2.1 seconds. From here, I'm actually able to figure out the speed as he crosses. Once he finishes accelerating, he's going to have a constant velocity to the finish line. So we can take the velocity right at 2.1 seconds, that is v of 2.1, is equal to 5.321 times 2.1. And this is going to be 11.1741 meters per second. This is the velocity when he finishes the race. From here, if you want to go further, you can figure out the distance that he accelerates, and then you can figure out the distance that he finishes the race with the 7.9 seconds left if you want to. This concludes the next kinematics problem, and if you have any questions, just comment on the video. Thank you.